Recently I had a little project here that I wanted to work on that required me to learn how to use the brains in Mach 3. So it worked out pretty well for me, so I figured I'd shoot a quick video and tell you all the stuff that I learned about brains in Mach 3. So here we go. So what happened, I started out, I hooked up the tachometer on my mini lathe, and I got to thinking about basically the only time I've ever had a crash on my little Chinese machine tools is when I've stalled the spindle out. This has happened to me twice, where I've stalled out the spindle, but Mach 3 just keeps on moving the axes, and then on my lathe it knocks my tool post out of whack. On my milling machine it knocks my milling head out of whack, which is no fun. So I thought, hey, there's got to be a way. I have the tachometer working in Mach 3, so I figured, hey, there's got to be a way to make it so if Mach 3 sees that the spindle stops, that it'll stop the feed rate. So I got it to work. So I have a little demo program here, so I'm going to turn it on, show you how it works. So I put a extra button on my screen so I can turn this function on. It's spindle 1 fluctuation detection. So I'm just going to go ahead and run my program. So here we go, it's sitting there. The yellow bar tells me that it's waiting for the spindle to be on. I have an optional stop, so let me fire this up here, and so here we go. So Mach 3 is ramping up. It wants to see 250 RPM, and there we go. So I got pretty close. So you notice I have a little light that basically this little light comes on when I'm within 90% of the program feed rate. So as long as I am within 90% of the program feed rate, everything is fine. As soon as Mach 3 sees the spindle drop below 90% of the program feed rate, it's going to stop the axes from moving. So let me just go ahead and simulate that. So here we go, cycle start. Everything's cool. It's coming down here to run this little dummy program that I have running, and let me just go ahead and simulate the spindle stopping. So I'm going to turn the spindle RPMs down, and there we go. So you can see what happened. It almost happened so quick I didn't notice it. As soon as the little light went out, it triggered the e-stop. So that, hopefully, if I turn it back up, well, let me reset e-stop. Hopefully that's going to prevent crashes from happening in the future for me in these cases where the spindle stops. Fire it up, run it again. So there we go. There we go. So that was a little project. So in order for me to get that functionality to work, I had to, it's hard to run my mouse with my left hand, I had to add a few buttons to my screen set, put a little tiny bit of VBA code on one of those buttons, and then write a brain. So let me go ahead and try to give you a super quick, hopefully easy little tutorial of how I did that, and hopefully that'll help you work in your projects. Alright, so let's get started. So the first thing you need to do is you need to start, well, I like to use screen 4 as the editor. So you have to start screen 4, and I'm going to try to do this, hold the camera with my left hand or the mouse with my right hand. So screen 4 is a little glitchy, so let me just load my dummy file, and for some reason mine needs to be loaded in 1024 by 768, and there we go. So there's the screen, and I'm just going to navigate over to the window that I want to edit. So here we go. So this is the button and the LED that we're going to add. So I'm just going to go ahead and delete these really quick. If I can, Let's see if I can do this with mouse. So let me delete that and delete that. So the first thing we need to do is we need a button. Oh, hang on. This is turn off the images. So this is one of the things about Screen 4 that's weird. It's glitchy. Okay. Now every time you click, now there's my button. Now I need a LED, so I'm going to pick none, and then I'm going to pick LED. So there we go. I have a button. And I have an LED. So let me double click on the LED. That's going to become OEM code 2000. That's my button. And okay. And then this, or I'm sorry, that was my LED. Now here's my button. And it's going to run VB script. And I'm going to just call this test. Oops. There we go. So the button says VB script, caption is test. There we go. And the LED is an OEM code 2000. So okay. So there we go. We've just added this to our screen set. So I'm going to save this, and then we're going to go and work with brains. Okay, here's the next step. So just loaded Mach3. I went to View, Load Screens, and I loaded this dummy temporary screen set that we just created. And now we need to put the VBA code into that button. That button is going to trigger this LED, and then we're going to use the status of that LED to turn off and on our spindle fluctuation. So we go to Operator, Edit Button Script. Notice all your buttons that are attached to VBA code blink. So this is when I create it. Click on it. Right now there is no code in it, so I need to paste the code into that button that makes it work. So I just happen to, for the sake of saving time, have this code right here. So let me copy and paste that out of here and throw it in here. Paste. So there it is. This is the code that is going to make it work. So we named that LED user LED 2000. So basically just says it says if user LED 2000 is true or equal to 1, then set user LED 2000 to 0. Otherwise, set user LED 2000 to 1. So this little bit of code is just going to, every time you press the button, it's going to toggle the status of the user LED 2000 from off to on. So there's the code for our button. So I'm going to say save, and I'm going to close it and minimize that. So hopefully now this works. Hey, there we go. So when I click on the button, the LED goes off and on. So, all right, so we're moving along. So we have the button and we have the LED. Now we need to write the brain. Okay, here's the next step. We're going to write a brain. So I'll go really quick here so I don't take up too much time. Let's go to Operator, Brain Editor, give it a name. I'm going to call it, try to do this with my left hand. I'm going to call it test, T-E-S-T underscore XXX, just so I know it's junk, test XXX. So now here we are, we have the brain editor screen, and you can watch some videos on brain editors. It will be better than what I can do, but really quickly, we're going to add some stuff on the left side of the screen, do some evaluations, and output something on the right side of the screen. So I'm going to add, so I'm going to press the plus button. I'm going to add some information from DROs, and I'm going to pick, the first one I want is the, I think it's called True Spindle, yeah, no, what is it? True, where is it at? Here we go. Spindle True RPM. I'm going to add that. I'm going to add another one, another DRO. and I think it's called command, here it is, command spindle RPM. So I've got true spindle RPM, command spindle RPM. So everything here is supposed to be pretty intuitive, and I couldn't figure out, I'm like, I can't highlight both of these at once to do an evaluation. Well, what I found out you have to do for some of these is pass the input. So I literally just highlight it. This intuitive window pops up. I don't want to do anything. I want to do no operation. Let's leave that checked and say, okay, and I've passed the value or the signal. Going to do the same thing here. No operation, pass the signal. Now I can highlight these two passed signals simultaneously and do some intuitive comparison. So I want to highlight them both, hit plus again. Now I'm going to, so you have a lot of things you could compare. I'm going to use a formula. Formula is really simple. The first thing is A, the second thing is B, right? So this is A, this is B. So I'm literally just going to do A divided by B. So I want to take the true spindle RPM divided by the command spindle RPM. And okay. So now that outputted a value. Now I want to take that value and I want to evaluate it. So now I'm going to take that and I'm going to do a compare immediate. And I'm going to say if that value is less than 0.9, do something. Okay, boom. So here we are. We have the two inputs, passed the values, did the math. Now I'm saying if that the result of that math is less than 0.9, do something. Now I got to terminate this lobe. So now I'm going to hit this other button, and now it's asking me, what do you want to do? So just to test this, I'm going to do a, I think it's a input or a button press. Let me just see, button press. I'm going to pick button press, and I'm just going to do a feed hold. So just to test it, I'm going to pick feed hold. And okay, so now here we go. So we have a whole part, complete brain built. True spindle RPM, command spindle RPM, pass the values, divide A by B. If A divided by B is less than 0.9, do something. So there we go. We have a brain that we can test. It's not the finished product yet, but let's test it. So I'm going to press save and save it. I'm going to close this. I'm going to go to operator and try to focus. Brain control. And I'm going to reload all brains. So there it is. There's our brain. Test XXX. I'm going to enable it. I'm going to reload the brain. So now that brain is enabled. Now I'm going to say view the brain. So now it gives us a real-time, whoops, close this, bring that back up here. It gives us a real-time view of the brain. So you can see right now it's reading the true spindle RPM is 77. That's just a glitchy thing Mach does because it stopped abruptly last time. It's reading the command spindle. So, well, let's go ahead and just do this. So let me go to an MDI, and I'm just going to give it a command of MO3 S250. Boom. So there we go. It thinks it needs to see a command of, or it's looking for spindle RPM of 250. So now let's bring the brain up and minimize it. So now as I turn my spindle on, you'll see what happens. So some numbers are changing, it's doing math. And there you go. As soon as we get over 0.9, it breaks the logic and feed holds turned off. Drop below 0.9, feed holds on. So there we have a functional brain. So now let's incorporate the buttons we created, because you don't want this brain to always be, like, you don't want this logic to always be in effect. So now let's go and re-edit that brain and make it use those buttons. Okay, so let's go and add the rest of the logic into this brain. So back to operator, brain editor, press cancel, and then file, brains test. Okay, so here we go. So let's finish this out. First thing I want to do is I'm not going to use feed hold, I want to use eStop. So I'm going to highlight this and hit the terminator. I'm going to say re-terminating lobe, and I'm just going to say remove terminator. So terminator has been removed. But we need some more logic. In addition to testing this, we only want this thing to happen when the feed rate is running, and then we only want that to work when we have that button pressed. So let's add the next input. So I'm going to do this, and we want another DRO. This DRO is going to be called blended feed rate. So we're going to pick that, blended feed rate, say OK, and then we're going to do the same thing. We're going to highlight blended feed rate. We're going to pass the variable, and then we're going to say compare immediate, and we're going to say greater than 0. So there we go. So we're only going to pass that variable if it's greater than 0. And then I'm going to highlight this and this, highlight that. I'm going to do this. I'm going to say and. So now the logic only goes through if this is true and if blended feed rate is greater than 0. But now we want to pick up that LED too. So I'm going to hit another input, and I am going to say LEDs right here, and this is a user LED, so I'm going to just tell it's user LED 2000. So that's how we pick up that LED that we created earlier. And same thing, I'm going to highlight user LED 2000. I'm going to say I think I want to do, well, I'm going to say no operation. I'm just going to pass the variable. And then I'm going to, let me look at my cheat sheet really quick. Hang on a second. I wrote all this down. Let me make sure. Let me look at the cheat sheet. I'll be right back. Okay, we're good. Cheat sheet helps a lot. So I'm not doing any evaluation. I'm just going to pass this now, OEM LED, and this. I'm going to highlight those, and I'm going to do another and. Now I got all the logic, so I'm going to evaluate true spindle divided by command spindle. If that's less than 0.9, it goes to here. And then I'm going to say, and if the blended feed rate is greater than 0, move. Now, if all that's true, and I've actually activated this function, the LED's lit, then go to the next thing. Now I'm ready to terminate the brain. So I'm going to highlight this, going to terminate. And in this case, I'm going to use eStop now. So now I'm going to do, I think eStop is under input. So I'm going to hit input and eStop. There it is, right there. eStop. Okay. Perfect. So now the brain is built. I'm going to save it. Brain is saved. I'm going to close it. I'm going to go to operator, brain control. I'm going to reload all brains. I'm going to pick test brain, and I'm going to view the brain. So here we are. We have the logic, and in order to test this logic, I need to turn on the spindle. So let me go back to quit mode. Actually, we need to run it in auto. So let's go to auto and cycle. I have this little dummy program. So let's bring up the brain, try to drag it out of the screen. I'm going to hit cycle start. So now it sees the spindle is looking for 250. Let's go to the brain. So right now, well, let's turn the spindle on. Let's see what it does. So here we go. Numbers are flashing. So right now I'm at 0.4, at 0.5. There we go. So now the logic, the first part of the logic, I am at 95% of the command spindle speed. So let me leave it right there. I am not feeding, and my LED is lit. So let's look at that. So if I turn the LED off, LED's off. Now that part of the logic went out. If I turn the LED on, now it's on. So now let's cycle the program. Let's allow the program to start move. So there we go. So now you can see blend it, feed rate. It knows it's, you know, the machine is moving. It's doing stuff. It's moving the tool. The LED is lit. So the only thing that's not breaking the only thing that's not allowing e-stop to get triggered is this logic up here. So let me simulate that by slowing the spindle down. There we go. Triggered the e-stop. So the logic worked. Now I think, my suspicion is that while this brain monitor is running, that the system runs a little slower. I actually think that it's more responsive when you're not running this brain viewer. So, so there it is. There's an example of a functioning brain, and hopefully that was enough of a walkthrough that you can go ahead and create your own brains and do some cool stuff. Here we go, one more time for emphasis. So cycle start, and we're not meeting the programmed feed rate or speed for the spindle, so let's turn the spindle on. There we go. Now we met it. Now we're going to let it feed. So there we go. Now we have a true condition for seeing a positive feed rate greater than 0. We have a true condition for the LED being on. If I turn the LED off, it goes off, so back on, off, on. So this is true, but this is all false, so we're not going to trigger the e-stop. But the moment that I stop the spindle, there we go. All the logic fails and e-stop is triggered. And like I said, I think this is more responsive when you're not running the viewer. So there you go. I hope this is helpful. Quick tutorial on Mach 3 brains. Have fun. Thanks.